Hello, my name is Anmol Dutt, and I'm gonna present a presentation of technology management project proposal. In the introduction of technology management project proposal, which is a rapid adaptation of AI, introduces both innovation and unknown security threats, which mean the financial services sector is aggressively adapting AI to improve insufficient and effectively decision-making customer experience, that is innovation acceleration and security uncertainty. The second one is financial services face high risk exposure due to mission critical infrastructure, which means the financial organization carrying mission critical infrastructure, meaning even small disruptions can cause massive financial, regulatory, and reputational damage. Key reasons including high value data and assets, interconnected systems, strict regulatory requirements, zero tolerance for downtime. And the third one is deepfake attacks and LLM-powered malware are emerging as a major threats, which is deepfake and deep attackers. These refers to attacks powered by deep learning to generate synthetic content and manipulate system behavior, such as AI generative voice to authenticate fraud transactions, deepfake video imprisoning executives, and deep AI attacks target the human trust layer and AI model layers, making them harder to detect. Strategic technology management is required to safeguarding assets and reputation, which mean to safeguard critical infrastructure assets and reputation. Organizations must shift from reactive security to a strategic AI-driven defensive framework. This includes governance and risk management, AI security architecture, threat intelligence, and conditional monitoring, workforce capability and culture, model infrastructure readiness, regulatory alignment, and ethical AI. There is a problem definition. There is a surge in AI-enabled deepfake attackers targeting financial institutions, which means financial institutions are experiencing a significant rise in attacks powered by AI models capable of generating synthetic voice identical to customers to executives, fake identity documents enabled through AI generative and fraudulent biometric data able to detect a facial recognition system. AI created behavior patterns to defend fraud detection models. And the second one is identity verification and authentication systems are being covered, which means that traditional identity verification processes such as voice authentication, video KYC, financial recognition, and document validation were not designed to counter AI generative synthetic media. Attackers now exploit these weaknesses by using deep fake voice during customer service authentication call, uploading AI generative ID documents that passes automated KYC checks, hijacking remote onboarding systems with AI generative videos feeds. And the third one is average financial loss per deepfake fraud incident reaches $600,000, which means recent incident analysis shows the average financial losses per deepfake enabled fraud incidents now reaches approximately $600,000, driven by authorized push payment fraud, compromised wire transfers, manipulated customer service transactions, deepfake enabled internal imprisonment, synthetic identity driven created, and credit fraud. And the last one is high profile incidents, including £25 million transferred due to AI driven scams, which is several high profile cases have shown the diversity capability of AI driven. One notable incident involved £25 million being fraud transferred after attackers used a fully AI-generated deepfake of a company's financial detect and during the video conference call matched the director's face used cloned voice patterns, successful introduced staff to authorize transactions. And that there is a problem definition strategic challenges. First is deepfake attackers pose significant challenges to regulatory compliance and risk management frameworks, which mean deepfake AI and AI generated attacks evolve much deeper than traditional fraud detection methods and legacy risk control. Key points is adaptive novel attack formats, high scalability, and the second one is AI-driven fraud evolves faster than current detection methods. First is the limitations of legacy system, which is many institutions rely on outdated infrastructure and legacy systems that are were not designed to counter AI-enabled fraud, which is rule-based AI and fraud detection, slow adaptation. And the third one is legacy systems and organizational resistance amplifying vulnerability, which is even when AI solutions exist, internal barriers often slow operations and adaptation. First is cultural resistance, process inheritance, skills shortages, and so on. And the last one is urgent need for adaptive, scalable, and automated defense mechanism, which is the address of evolving threat of deepfake AI threats. Attacker financial institutions require adaptive AI detection, scalable deployment, automated response mechanisms, integration with organizational workflows. Proposed solution overview, which means the solution was a four-layer deepfake defense system that included AI, which means these components work together to form an end-to-end security ecosystem that continuously analyzes threats, confirms identity integrity, and responds instantly to anonymous AI enhanced detection, adaptive authentication, real-time incident response. The second one is continuous improvement response detection and authentication layers, which mean the defense system integrates three interconnected AI engines that reinforce such as productive AI, proactive defense, and the second one is detective AI, real-time monitoring, response AI, autonomous defense, and the last one is reduce manual workload while strengthen fraud resilience. And the third one is it combines multi-model biometric ML models and real-time incident response, which means the solution enhances identity assurance by incorporating multiple biometric and behavioral signals rather than relying on a single method. This includes facial recognition with deepfake resistance, voice biometrics with liveness and anti-spoof analysis, fingerprint and device-based authentication, behavioral biometrics, typing pattern, navigation system, device usage. And the last one is an adaptive system premises continuous security against device threats that arises due to AI, which means the system employs ML and DL, which mean machine learning and deep learning models specifically trained to resist AI-generated attacks. Adversely fraud detection models, which means models are exposed to simulated deepfakes, synthetic models, and documents and inputs and improve robustness, which means a dynamic model retrain assemble models. Core technologies are deep learning based models that identify audio, video, and image manipulation, which mean modern attackers use generative AI to produce synthetic voices, manipulated videos, of identity documents, and images. Deepfake detection network and trained to detect face immigration and micro irregularities. multimodal biometric authentication, face, voice, and behavior analysis, which mean facial biometric, voice biometrics, behavior biometrics, and device and environmental biometrics, which means GPS consistency, device fingerprinting, network characteristics. And the third one is real-time incident response with automated alerts and forensic analysis, which means real-time blocking and migration, automated alerts, forensic analysis engine, and the real-time defense prevents fraud while reducing manual workload and response time. And the last one is continuous model retraining and threat intelligence integration for adaptive defense, which mean automated model retraining pipelines, adversely training performance monitoring, and models are monitored for drift, bias, and accuracy degradation. Architectural integration, which means the detection layer analysis digital inputs for manipulation. Authentication layer fuses multiple biometrics with anti-spoofing control, which means the architecture begins with the detection layer responsible for analyzing all incoming digital content and behavioral signals. This layer uses advanced deep learning models to detect manipulated media, deep fake audio, synthetic video streams, AI-generated identity documents, and adversely input. Authentication layer fuses multiple biometric with anti-spoofing control, which means if the detection layer identifies credible signals that system transactions to the rigorous multiple model biometric authentication processes, this layer validates identify with the multiple factors to ensure strong AI resistance verification. First is facial biometrics with liveness detection, voice biometric, behavioral and biometrics, environmental and device level control. Response layer triggers alerts, blocks transactions, and supports compliances, which means automated blocking, transaction risk-based decisions, targeting alerts to security teams, and supporting logs. Continuous improvement layer refines the models using prior incidence insights, which means the final layer ensures the architecture never becomes outdated or vulnerable as AI-driven threat evolve. Model refining pipeline, feedback loops, threat intelligence integration, performance monitoring, and so on. And here is the project plan, discovery and assessment, analysis of technology requirements and assessment of potential threats, which means the project begins with the comprehensive discovery phase to understand an institution's current security posture, technology landscapes, and operational constraints. Key activities like identify business objectives, regulatory obligations, and operational requirements. And the second one is assessment of potential threats, which means the structural threat analysis is conducted to identify a full spectrum of AI-enabled tricks. And the third one is the development of enterprises architectural model. First is and the second is the development, which is AI model creation infrastructure setup AI phases, which mean the structured threat analysis is conducted to identify a full spectrum of AI enabled risks like deep fake audio and video records, synthetic identity creation, AI driven social engineering, identify manipulation in onboarding and authentication. And the third one is deployment phase introduction, pilot testing, and performance monitoring, which mean an enterprise architectural blueprint is designed to ensure the defense system can be integrated seamlessly across the organization. Key components, system architecture layers, detection, authentication, response, intelligence logging, security architecture, and audio architecture. Continuous improvement, system operation and optimization, retraining the threat updates, which is the system requires secure, scalable infrastructure to run AI models, handle biometric data, and support real-time analysis. Cloud environment configuration, AWS, Azure, GCP, or hybrid, which is network configuration and zero trust security setup, deployment of a platform, doc logger, and login monitoring. And there is a success factors. Executive leadership and governance support are critical for adaptation, which means a strong executive sponsorship is essential for driving AI security transformation, AI enabled fraud defensive requirements. Like first one is a clear strategic direction, robust governance framework, cross department coordination. Second one is investment in cloud AI infrastructure and secure API integration, which mean a model AI fraud detection depends on scalable high performance technology foundation, which means cloud computing for scalable processing of biometric and deepfake detection. And the third one is workforce and deployment and upskilling in AI, ML, and cybersecurity practices, which means AI models must integrate seamlessly with authentication, fraud detection, transaction monitoring, and compliance systems. Critical requirement API gateways with zero trust authentication. Alignment, and the last one is alignment with strategic compliance and transparent performance metrics, which mean an AI-driven defense ecosystem requires teams who understand both AI ML technologies and cybersecurity practice. Here is the key challenges. First is resilience to change in the organization, fear of disruption of the workflow, and the possible outcomes on productivity, which means implementation AI-enabled security systems requires major shifts in process, roles, and definition, decision-making models. Employees may fear job displacement, automation, and transactional and traditional security roles. And the second one is false positive and blocked transactions are caused by the limitations of AI detection, which mean integrating new AI systems can temporarily disrupt existing optimal flows, particularly during testing, training, or pilot phase. And the third one is large scale deployment is expensive with the uncertainty of the ROI, which means AI models, especially in fraud detection, sometimes misclarify legitimation transactions as fraudulent. These fake positives can fraud customers and disrupt operations. Key challenges customer dissatisfaction due to legitimate transaction delays. And the last one is moral and social consequences, such as the problem of privacy and fairness, which mean deploying large-scale AI defensive and security of AI-based fraud systems operation and operate within strict regulatory frameworks. And the last one is conclusion. AI-driven deepfake attacks pose complex and evolving risk of financial services organizations. The second one is the proposed layer defense workforce provide comprehensive production and operational adaptivity. First is nature of the risk. Dynamic and evolving attackers continuously improve their AI models. High financial impact. Successful attackers can lead to millions in fraudulent transfer, regulatory fines, and costs. And the second one is the defense frameworks and its compatibility. The proposed framework offers comprehensive protection across multiple dimensions, multi-layer detection, adaptive authentication, real-time response, continuous improvement, and the feedback loops. And the third one is successful implementation relies on strong leadership, robust infrastructure, workforce readiness, and regulatory compliance, which means effective deployment of the framework relies on a combination of people, process, and technology. strong leadership, robust infrastructure, workforce readiness, regulatory compliance, continuous monitoring and improvement. And the last is ongoing continuous improvement ensures lasting resilience against emerging AI-enabled fraud threats, which means when successfully implemented, the defense framework provides comprehensive protection against AI-enabled fraud, operational resilience through adaptive real-time detection and response, sustainable regulatory compliance, and ethical oversight, continuous adaptation to new threats, maintain long-term organizational trust.